All right, hi everybody. This is your lesson video for 6.6 recursive sequences. And how can you define a sequence recursively? So first of all, what recursive means is it's really not as difficult as it might sound. Recursive is just describes what the pattern is algebraically. Okay, so we've done arithmetic sequences, we've done geometric sequences, and when we did them, we were using these formulas here, these equations. And these are very helpful in finding any term, all right? If we're looking for the nth term, so the 180th term, we could plug 180 in here with the first term and then the common difference and find out what that value is. Same thing with geometric. All right, if we're looking for the 57th term, it would be a 57 and then plug 57 minus 1 and figure out what that number is. Recursive equations, all right, so we have those are explicit equations, so explicit is what we've been working with. Recursive equations for arithmetic and recursive for geometric, they describe what the pattern is, like what's happening each time. So, and doing that in an algebraic way. So if we're looking at the recursive equation for arithmetic sequence, which is an equals a to the n minus 1 plus d, all right, an is the new term. That's what we're looking for. All right, an minus 1 is whatever previous term we're going to be using. And then d for arithmetic is the common difference. All right, so whatever we're looking for, and then this one is the previous term that comes before that, and then d is a common difference. So once we break it down, it might look confusing, but it's really not once we start getting into it. Same thing for a recursive equation for geometric sequences. The an is the new term. All right, r is the common ratio. And an minus 1 is your previous term. All right, so on A and B, they say write the first 6 terms of the sequence, then graph the sequence. So you can see where it says an, a2, all right, that's the first term, that's the second term, third term, fourth term, fifth term, sixth term. They gave us the first term is -2, so we really don't have to do anything in here. When we're looking at this, so the first term, they also say the first term here, all right, a1 is -2. And then you can see that to find the next term, it's -2 times the previous term, all right, -2 times the previous term. So since it's being multiplied like that, we can automatically assume that this is a geometric sequence. So for a2, we're going to have -2, so it's -2 times the previous term, which is -2. So this -2 is here, and then this -2 is the previous term, which equals 4. So our second term is 4. Now to find a3, it's -2 times the previous term, which is 4. So that's -8. Fourth term, -2 times the previous term, which is -8. So that's 16. Fifth term, -2 times previous term of 16, so that's -32. And then the sixth term, bringing that -2 times the previous term, -32, which is positive 64. Now to graph this, we do have some negatives and positives. So when we sketch our coordinate plane, we want some positive and some negative. So I'm going to keep this as my y. And then I want to get to at least -32. And then I got to get up as high as 64. So if I go 10, 20, 30, 40, 50, 60, 70. So if I go by tens, then -10, -20, -30, okay. So I'm going to make my x coordinate here. And each of these are going to be 10, 20, 30, 40, 50, 60, 70, 80. And then this would be -10, -20, -30, -40. And then, so these are my my patterns here and my results, and these are my terms. So my first term, can I skip everyone here? So 1, 2, 3, 4, 5. Yep, we can do that. We can spread it out a little bit. So 1, 2, 3, 4, 5, 6. So my first term is -2. All right, so that is going to be pretty close to this line. And plot a point there. Second term is 4. So right about there. And you see how it's down in the negatives and then up to the positives. Now for my fourth term, I'm going to come back down to the negatives, and it's -8. So right below, we're right above that -10. And then fourth term is 16. That's 10, 20. So 16 would be here. Fifth term, -32. This is -30, -32. And sixth term is 64. Okay, so you see it's kind of a sloppy graph. All right, we don't have a curved line or a straight line. It kind of goes back and forth, jumps back and forth, positive, negative, positive, negative. So looks kind of funny, but that is the graph for that sequence. All right, let's look at another one. We can see that this is geometric because it's 1.5 times the previous term here. My first term is 4. So, and it's 1.5 times the previous term. So for my second term, I'm going to do 1.5 times 4, which equals 6. Third term is 1.5 times 6, which equals 9. All right, fourth term, 1.5 times 9 equals 13.5. 1.5 times 13.5 is 20.25, and then 1.5 times 20.25 is 30.375. Okay, so just kind of circling back here, Now this equation is describing, when we talked, how can we define the sequence or describe the sequence? So this sequence, each term is found by multiplying the previous term by 1.5. So that's the description. Same thing over here. This sequence is found by multiplying -2 by the previous term. So that's what these equations are showing us. We're going to graph these. Now, all of these are all positives, so we don't have to worry about a negative value. So I'm just going to use quadrant 1. All right, so there's my y values, my x values. That's 0, 1, 2, 3, 4, 5, and 6. I want to get up to 30. So if I go 5, 10, 15, 20, 25, 30, that should get us to where we need to go. So we have our first term is 4. So here's first term, 4 will be right underneath the 5. Second term is 6, so right above the 5. Third term, 9, right below the 10. Fourth term is 13.5. All right, that's 12.5, 13.5, so somewhere around there. Fifth term is 20.25. And then sixth term is 30.375, so something right about that. All right, on C, you can see this is a little bit different. All right, our first term is 14. All right, but now our previous term is having 4 subtracted from it. So this is not a geometric, all right? This is the tell that it's an arithmetic sequence because it's -4 not being multiplied. So previous term -4. So on this one, term 2 would be 14 minus 4, which is 10. And then it's 10 minus 4, which is 6. 6 minus 4 is 2. 2 minus 4 is -2. -2 minus 4 is -6. So we do have some positives and negatives in here. If we go by 2's, we can make this our x-axis. All right, so now we know we can capture some negatives here, positives here. We have 0, 1, 2, 3, 4, 5, and 6. 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's 0, so that's -2, -4, -6. So I think that gives us everything that we'll need. We have 1 is 14, so plot a point there. 2, 10. All right, 3, 6. 4, 2. 5, -2. And then 6, -6. All right, D, why don't you pause the video here and why don't you give D a shot and then come back, fill out the table, fill out your graph, and then come back and check. You can see that it's the previous term plus 2. So I will tell you that this is arithmetic. All right, our first term is -3. All right, and then you're adding 2. So complete that table and then sketch out your graph. All right, welcome back. So for your sequence, you should have come up with -3, -1, 1, 3, 5, 7. So I actually went too low here, and so I had to extend my graph to -3 here for 1. All right, and then 2 is -1, 3 was 1, 4 was 3, 5, 5, and 6th term is 7. All right, on E and F, we're going to write the recursive rule, the recursive equation. To do that, we're going to have to determine whether it is a geometric sequence or arithmetic sequence, because both have different recursive equation like formulas. So remember, geometric, that is going to be AN equals the ratio times AN minus 1. And then arithmetic, all right, that is AN equals AN minus 1 plus D. Okay, so you can see the arithmetic in there, and you can see the geometric there. So depending on what the sequence is, that's going to be your basic equation that you use to write the rule for each sequence. So let's look at E. First, let's determine if it's geometric or arithmetic. So we're going to do our previous term, or second term over our previous term. So that's 108 over 324, and that is 1/3. And then we have 36 over 108, and that is 1/3. And then you have 12 over 36 to be 1/3 as well. So R is 1/3, and then when we have our basic equation, our basic rule, we have AN equals 1/3 times the previous term, so times AN minus 1. So, and then the first term is, it's always nice to show what the first term is 324. Okay, so write the rule. Here's the rule starting at 324. All right, F, we have 14 over 9. Is 1.5 repeating. 19 over 14 is 1.35, so it's not geometric. All right, 9 plus 5 is 14. 14 plus 5 is 19. 19 plus 5 is 24. So this is arithmetic. So we're going to use the recursive arithmetic formula. So we have D equals 5. So we have AN equals the previous term, AN minus 1 plus 5. And then our first term is 9. So we're going to add 5 to our previous term. and starting with 9. Write the recursive rule for the sequence. So we have 3,125, 625, 125, 25. Got 625 over 3,125. And that is 1/5. 125 over 625 is also 1/5. And then 25 over 125 is 1/5. So we do have a geometric where r is 1/5. So we're looking at our geometric formula. We have an equals 1/5 times an minus 1, with our first term being 3,125. All right, we have negative 24 over 8 is negative 3. 72 over negative 24 is negative 3. Negative 216 over 72 is negative 3. So r is negative 3. We have, so it's geometric. So an equals r, which is negative 3, times a times the previous term. And then our first term is 8. All right, now in this one, you can kind of see that it's plus 6 each time, so that makes it arithmetic. So on this one, we're going to use the different one. We have an equals an minus 1 plus d. D here is 6, so let's just substitute that in. So it's an minus 1 plus 6, and then a to the first equals 7. All right, write the recursive rule for the sequence. So these are just, our first term is 15, second term is 12, third term is 9. So don't let the graph confuse you. If we wanted to list it out based on what we've already learned, this would be 15, 12, 9, 6, and 3. So you can see it's subtracting 3 each time. So this is an arithmetic. Where d is minus 3. For our arithmetic recursive rule, all right, that's going to be an equals the previous term, an minus 1, all right, plus d. So in this case, all right, a1 is 15, d is minus 3. So we have an equals an minus 1 minus 3. All right, 9. Here we have first term is 20, second term is 4, Third term is 4/5. Fourth term is 4/25. Fifth term is 4/125. So we have 4/20, which is 1/5. And if we do 4/5 divided by 4, all right, that's 1/5. All right, so we have a geometric here, and R is 1/5. So for the geometric equation, we're going to do AN equals R times the previous term. So AN is 1/5 times AN minus 1. And then A to the first is 20. All right, on L, M, and N, they are giving you the recursive rule, and they want you to write going back to the explicit rule. So when we do this, we already know what the first term is, and we also know what we know that this is a geometric sequence because 3 is being multiplied with the previous term. So it's a geometric term, and our ratio is 3. All right, and when we have those two things, we have everything that we need to know to be able to write the explicit term, because the explicit term for geometric, and this is on the front of your notes, the explicit term was AN equals the first term times R n minus 1. So on this, we know what we have A to AN, and our first term is 4. R to the n minus 1. And really, that's as far as we can take that. They're not asking us to evaluate for a specific term. All right, M, we can see that it is arithmetic because the previous term is being added. 11's being added there. So it's arithmetic. And the arithmetic explicit is AN equals A1 plus n minus 1 times D. So we know what A1 is. A1 equals 6. And then D equals 11 with that plus 11. So we have AN equals, first term is 6, plus n minus 1 times 11. Now, we can simplify this more. You know, when we have parentheses in an equation, our equation's no longer, is not simplified yet. So what you want to do is do your distributive property here and here. So that would have 6 plus 11n minus 11. And then we have like terms of a positive 6 and a negative 11. So when we combine like terms there, we end up with 11n minus 5 for our recursive rule. All right, whatever the term is being multiplied by 11, and then we're subtracting 5 from it as the description. All right, why don't you pause the video here and you can do n. You can see that it's a geometric because 5 is being multiplied. All right, welcome back. Let's see what you got. Our first term was -1, and then it's 5 being multiplied by the previous term, so r is 5. So it's an, first term -1 times 5 to the n minus 1. All right, O, P, and Q. Now they're giving you the recursive rule, and you want to write the explicit rule. So geometric, explicit rule is an equals a1 r minus 1 for arithmetic. All right, that is an equals a1 plus n minus, doing this backwards. All right, so that's the explicit. All right, they want us to write the recursive. So arithmetic recursive is an, all right, previous term plus the difference. Geometric recursive, an equals r times the previous term. So here we have an, 6 times n plus 2. Now on these, all right, d, all right, the difference is actually what's being multiplied with n. So d is 6. And then to find a1, where we can use this equation to find the term. So if it's a1, and this is our equation, this would be 6 times 1 plus 2. So 6 plus 2 is 8. So therefore, a1 is 8. So when we're doing our arithmetic rule, we have an equals previous term plus d. So in this case, it's an previous term plus 6. All right, so for this, it is geometric. All right, because that is the geometric explicit rule here. So, and r is -3. So we just have to find a1. And in this case, it would be -3. All right, 3 minus 1. I'm sorry, 1 minus 1 is 0. All right, so that would make that 1. So then we have for geometric, all right, we have that rule. So it's an r. So an1 times, -3 times an minus 1. All right, our last one is similar to O, so this is arithmetic with D being -2. All right, A1, we would do -2 times 1. So that's -2 plus 1 or -1. So we have our first term, and then we have D. So it's an equals an minus 1 minus 2. All right, our last three here are not geometric or arithmetic, so these are similar to the Fibonacci sequence. So we want to discover the pattern, and even though it's not like a consistent pattern like that with a common difference or common ratio, we can write a recursive rule describing the pattern. So here we have 2, and then 4, 6, and then 10, and then 16, and then 26. So our first term is 2. If you notice the pattern, the two previous terms, 4 plus 2 is 6. And then these two terms, 6 plus 4 is 10. These two terms, 10 plus 6 is 16. These two terms, 16 plus 10 is 26. So it's basically adding the two previous terms to get the next term. So if an is the new term, then an minus 1 is the previous term, and an minus 2 is the second previous term. All right, so in this case, our two previous terms were added to get the new one. So our new term equals our second previous term added to our previous term to get our new term. So then we can use this to find our next two terms. So we have an equals our next two terms. This would be 16 plus 26. All right, when we do that, we get 42. And then our next one would be now 26 plus 42, and that would be 68. So we have 42 and 68. All right, S, we have 1, 3, negative 2, 5, negative 7, 12. So if you notice, this is kind of the opposite of R. 1 minus 3 is negative 2. And then 3 minus negative 2, we do keep, change, and we get 5. Negative 2 minus 5 is negative 7. 5 minus negative 7 is positive 12. So our new term here is taking our two previous terms, so n minus 2, and we're subtracting the next term. So here is our rule. So our next one would be negative 7 minus 12, which is negative 19. And then 12 minus negative 19, keep, change, and that is 31. So we have negative 19 and then 31 for our next two. Okay, and then our last one. So 2 times 1 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 4 is 32. So our two previous terms here are getting multiplied together. So our new term, we take an minus 2 and we multiply it with an minus 1. So that's our rule, our recursive rule. We're taking our two previous terms and multiplying them. So on this one, we have 8 times 32. And that equals 256. And then 32 times 256 is 8,192. All right, that's it for your lesson video for 6-6 recursive sequences. See if you can get started on your homework. If you would like to see additional problems from your homework, check out the homework help video to help you get that all finished up. All right, that's it for now. Have a good night. Talk to you soon. Bye.